Now that we've talked about the basic features, let's begin the discussion of the more advanced features, starting with really the entry point into a completable future, which are the so-called factory methods. So these are the pieces here. You can see that there are actually 4 of them. They represent a relatively small percentage of the overall methods that are in the completable future API. So factory methods are used to initiate asynchronous computations. And I actually asked ChatGPT to generate me a diagram that showed factory methods, and that's what it came up with. I guess it's kind of cool. You can push buttons and make stuff, kind of like 3D printing or something like that. So this, of course, is based on the factory method pattern that's in the Gang of 4 book. The computations that are provided with factory methods may or may not return a value. You can see that there's 2 sets of them. There's the supplyAsync set and the runAsync set. As we will see, supplyAsync returns something, and runAsync does not. You can see that because it returns a completable future to a void, whereas the other ones return a completable future to type U, which is a parameter to those methods. There are also static methods, by the way. SupplyAsync allows 2-way calls using a supplier. So you can see here what we've got. We've got this version of SupplyAsync that takes a supplier by itself, 1 parameter, and it returns a completable future that contains the results of the supplier. And the behavior is to asynchronously run the supplier in the common fork join pool. So by default, you get the common fork join pool, very much like Java parallel streams. The second parameter for supplyAsync takes a supplier and an executor. Also will return the results of calling the supplier. In this case, however, the supplier is going to run asynchronously in whatever context is provided by the executor, which could be some other fork join pool besides the common fork join pool. Could be the common fork join pool, but why would you ever do that? Just use the default parameter version here, the first version of this. And it could also be an executor that points to some other kind of thread pool, like a fixed size thread pool, a cached thread pool, your own custom thread pool, whatever you want to do. So those are ways of being able to customize the behavior. The other thing you can do, even though it looks at first glance like you can't pass parameters because supplier doesn't, quote, take parameters, in fact, you can pass parameters by using this type of technique, where you can see we have F1 and F2, which are strings, and we pass them in here into the call to supplyAsync. And this is commonly known as effectively final objects. And if you want to read more about that, you can take a look at this link. But in a nutshell, an effectively final variable in Java is one that's set but not modified up to the point where it's used. So that makes it effectively final. It's set, but it's not changed. You don't have to actually say it's final. So that's how you can pass parameters to supplyAsync. And supplyAsync, as you can see, returns a value. So in this case, it's going to return a completable future to a big fraction that will be the result of multiplying the 2 big fractions together. The thing to keep in mind here is that this computation, this one that's here, this one that we're running here inside supplyAsync, that runs in the background. So it runs, in this case, it would run in the common fork join pool. runAsync, similar idea, except it's a 1-way operation, realistically 1-way operation. It takes a runnable, not a supplier, because that doesn't return a value, and it will return a completable future with no result, but you can still join it if you want. So you can wait for the computation to finish asynchronously, but you will not get a result. And by default, it runs in the common fork join pool. There's also a version where you can pass in an executor, just like you do with supplyAsync. Here's an example of how you would do this. Once again, we're going to pass parameters into runAsync's supplier lambda here. And this does not return a value because void is a non-return type. So keep it in mind, there's this subtle distinction. You can't get a value back, but you can get back a completable future that you can wait for until it's done. As a consequence of all this, if you want to do anything useful in runAsync, you need to have an operation that has some kind of side effect. So in this particular case, the side effect is to print the results out to the standard output. And that will be printed out in a background thread. Whereas before, what we could have done is we could have had this thing run in the background thread and then arranged to run it in some other thread to get the final result. But this one will run in the background thread where runAsync operates, which will come out of the common fork join pool in this particular case. People typically use supplyAsync a lot more commonly than they use runAsync because you typically want a result back and you want to do something with that result. You want to chain it and transform it and depend on its value for some later operation. So supplyAsync is typically the thing to use. The functionality, as we talked about for both supplyAsync and runAsync, runs in some executor context, which is typically a thread pool. And as we've talked about before, the use of thread pools for executing these operations asynchronously helps to make your programs more elastic because you can scale up by having multiple cores be responsible for running the operations. Again, by default, the common fork join pool is used for these two methods that take no parameters, or you can override them with whatever you want. Keep in mind that one of the main differences between the Completable Futures framework and the Parallel Streams framework is that Parallel Streams does not give you the ability to select what thread pool to use. It really wants to use the common fork join pool. You can make it work if you really put your mind to it, but it's not worth it. Okay, so that is the end of factory method overview.